With the upcoming solar eclipse, I want to talk very briefly about how we can observe this event in a way that is safe. We never want to stare at the sun directly, and certainly never with binoculars or ordinary telescopes, because that could seriously damage our vision. To understand why, we need to know a little bit about how our vision actually works. At the front part of our eye, there is the cornea and lens that together focus light that enters our eye in such a way that it forms an image of whatever we're looking at on the back side of our eye, what we call the retina. We can simulate this using a glass lens and a piece of paper. So I've got a light source over here. We are going to generate an image of this lamp onto the piece of paper using the lens. So if I have that light from the object go through the lens, and the piece of paper is just the right distance away, then we can generate a nice clear image of that lamp onto the piece of paper. Notice it's upside down, and if I'm a little bit too close or a little bit too far away, if the lens were not quite the right shape, we'd get that blurry image. But if I get it just the right distance away, we get this nice clear image. And this acts in exactly the same way that our eye does. This would be the cornea and lens of our eye, and the piece of paper would be our retina. The light from the object that we're looking at is literally projected onto the back surface of our eye, the retina. And this contains all of the light-sensing cells, and those cells send signals to our brain, and our brain then converts those signals into what we perceive as vision. And again, for ordinary objects, when looking at ordinary everyday objects, this works really well. But we want to know what unfortunate things would happen if we try to stare at a very, very bright light source like the sun directly. So we saw how the lens and cornea of our eye will basically focus light in such a way that we can generate an image on the backside of our eye, on the retina, and that's how we see. So here's why we want to be very careful during something like an eclipse, that we don't stare at the sun, because that sunlight, that light that's coming in, that carries energy. And the lens of our eye will focus that light, and if our eye is absorbing too much energy, or any object is absorbing too much energy too quickly, that object is going to heat up and it can actually burn. So that's what we're going to do a quick demo with here. So I've got my lens, we've got sunlight coming in, and let's say I aim some of that sunlight at this white piece of paper. So if I aim my lens and I'm the right distance away, notice that that piece of paper gets very, very bright. If I'm aiming that in the right direction, that spot on the paper is very, very bright. Right now, when it hits the white part of that paper, that light energy, most of it is reflecting off of the paper and going in different directions. So it looks really bright to my eyes. Let me see if I can zoom in on this a little bit. It looks very bright to my eyes, but it's not actually causing the paper to catch fire. And again, this is what would happen for your retina if you are staring at the sun. But our retina is not reflecting light like the white paper. Our retina is absorbing light like the black piece of paper. So if I take this same beam of light and aim it on the black paper that absorbs rather than reflects that light, notice if I've got the right distance and it's not cloudy, we can literally burn our retinas. So when we're trying to observe this eclipse, and we're trying to do so safely, we always want to make sure that any observation, any experiment we're doing that experiment safely, because we do not want this to be our retina. So how can we observe this eclipse safely? Well, the first thing is to get a pair of eclipse glasses with the proper ISO certification. I'll put a link below for reputable vendors and the specific certification for that. Do not use glasses if you saved them from a previous eclipse, because the protective filters on them only last a few years. And when you're looking through them in an ordinary room, you should not be able to see anything. Even if I look directly at one of those overhead lights, I can't see a thing in an ordinary room. When you look at the sun with these on, the sun is the only thing you should be able to see. In contrast to this, sunglasses would not be sufficient. Sunglasses do not offer the kind of protection that you need to observe the eclipse safely. But another thing that you can make is a pinhole camera. And I did this very, very basically using an old cardboard box. Basically, have that cardboard box, cut a hole into it. I put two holes here, one larger and one smaller, so we can observe the differences between those. And on the inside of this, I just taped a piece of paper to act as a better screen. Okay. When the light comes through, when you aim this at whatever object you're looking at the eclipse, when the light goes through, it will project an image of that light source onto that screen on the other side. Now, if you use a smaller hole for your pinhole camera, you'll get a more focused image, but it will be dimmer. When we're observing the eclipse, having it be a little bit dimmer is probably not going to be a problem, so a small hole for your pinhole camera is going to be fine. But if you go with a larger hole, more light is making its way in, but that image is also going to be blurrier. So let's have a look at these particular effects with this pinhole camera. So the light source that we're going to use as our target is one of these swirly light bulbs. I thought that would be a more interesting target for us to use, so let me turn that on. And since it's going to be hard to see from this camera when I'm looking inside of this pinhole camera, I'm going to use my phone to get an image of what's happening inside of the box itself. Again, the covering of the box is going to get rid of more of the other ambient light that's going to kind of spoil our image. And if I look around and figure out where that light source is, there we go. What's happening is the light is going through those two holes. On the left side is the larger hole, the right side is the smaller hole. So notice that the left side with the larger hole, it's brighter, but it's a lot blurrier. On the right-hand side, where it's the smaller hole, the light is going through that smaller hole, it's dimmer, but it's a more clear image. And this is again, the basic design of how we can make one of these pinhole cameras. And the day of the eclipse, since the sun is very, very bright, it's going to be really, really easy to make these kind of pinhole cameras. You can just take a piece of paper, stick a little hole in the middle of it, and hold that over the sidewalk. That'll work as a pinhole camera. I've seen people use colanders with little holes all over the place, and each of those will act as its own little pinhole camera. I've seen people use Ritz crackers and the small holes in a Ritz cracker to generate these images. You can even just take your fingers and hold your fingers like this, and those little gaps will act as pretty good pinhole cameras. So these are some of the ways that we can observe the eclipse, look at some interesting kinds of science, and do so in a way that is safe.